Dear students, today we'll discuss physiology of high altitude, NMC competency PY 6.4. Now, high altitude, why we should know physiology of high altitude? Almost 1/5 of Earth is basically covered by mountains. Around 38 million people live permanently at altitude of around 2400 meters, which is around 10,000 feet, and around 100 million people travel to high altitudes locations each year for trekking and so many other purposes, for roaming at Himalaya region, at Mount Everest and at other places. Apart from this, skiers are there, trekkers, climbers to the Everest, and especially our military personnels deployed to high altitude locals are at risk of developing acute mountain sickness. So due to this chunk of population, we should know what are the physiological effects of going at high altitude. So when we ascend to a high altitude, subjects the body to decreased barometric pressure. As you are going above sea level, the barometric pressure goes on reducing. That results in decreased partial pressure of oxygen in the inspired gas in the lungs. We have seen that at sea level, the partial pressure of oxygen in the inspired air is around 160 millimeters of mercury, but as you ascend up, the barometric pressure reduces. So in the proportion, partial pressure of oxygen also reduces, leading to ultimately at diffusion it affects, because we know that important factor affecting diffusion is pressure difference of gases. So this changes leads to less pressure, driving oxygen diffusion from alveoli throughout the oxygen cascade. Means not simply at the lungs, at all places it is going to affect. So this leads to the basic problem of high altitude, that is hypoxia. So hypoxia is the basic physiological pathological abnormality which results from going at high altitude, and this leads to cascade of subsequent reaction. Just to rewind, hypoxic definition is a deficiency of oxygen in the tissue. So this is called as hypoxemic hypoxia. Here now main culprit is above the lungs. Lungs may be perfectly normal, but if the inspired air is having reduced amount of oxygen, that is going to affect. Now let's see what are the initial effects happens. Obviously, O2 available to the cell is insufficient to maintain aerobic metabolism that is adequate to carry out normal cellular activities. If you come down to human body, each and every organ is made up of nothing but tissues. Tissues is made up of cells. So ultimately each cell requires oxygen for the aerobic metabolism. So if oxygen is deficient or reduced amount, this will lead to anaerobic metabolism stimulated, leading to generation of increased level of lactate and hydrogen ions and subsequent formation of lactic acid. This will lead to net result in decrease in the blood pH, which is the main culprit of consequence of hypoxia. So if you are going to high altitude, your blood pH is going to get altered. So this decreased pH is dangerous for all body reaction. If you go back to biochemistry, all the body chemical reactions are taking place in a very limited range of pH. Slightly acidic, all enzymes are inhibited. Alkaline, all enzymes are stimulated. So we have to maintain the pH at very delicate balance. So this pH alteration leads to all inhibition of all enzyme activity. This will lead to suppression of all enzymes. Muscle fatigue will take place. All the at neurological places will have an effect. So the effect which is elicitable, that is acute effect of hypoxia. Acute means immediate. When you are exposed to hypoxia, immediate effect is basically decreased mental proficiency, as oxygen is deficient for the all activities, which decreases judgment, memory, and performance of discrete motor movements are reduced because of this. So these are the immediate effects of hypoxia which is elicitable. Now the effects basically starts at around altitude of 12,000 feet. So initial effects are, initial symptoms of hypoxia is drowsiness, lassitude, mental and muscle fatigue, and sometimes headache and euphoria. If a person stays at 15,000 feet for 1 hour, mental proficiency ordinary falls to 50%. And after 18 hours at this level, it falls to about 20%. Above 18,000 feet, twitching and seizure takes place. All the neurons becomes very irritability takes place, and ultimately at 23,000 feet, coma followed by death. So these are the consequences of acute mountain sickness. If the person is exposed rapidly to this altitude, it can be dangerous to the person. So people who ascend rapidly to high altitude, the sickness begins in a few hours up to 2 days. It is called as acute mountain sickness, but it is easily reversible. You descend down or supply immediately the breath oxygen, the person, he will get, all things will get reversed. But if it remains for some time, that can lead to dangerous condition called as acute cerebral edema due to vasodilatation, and acute pulmonary edema will lead to vasoconstriction. These two are the dangerous conditions which can happen. So we have to prevent them. So the best possible is immediately we have to supply the pure oxygen is supplied, so that process can get reversed in few hours. But if the treatment is not provided, means oxygen is not provided, and person is remaining at that altitude for some unavoidable reason, subsequent consequences can be dangerous. Impaired cerebral autocirculation in the presence of hypoxic cerebral vasodilatation, and altered permeability of blood-brain barrier due to hypoxia-induced chemical mediators like histamine, arachidonic acid, and vascular endothelial growth factors may all contribute to brain edema. So these are all dangerous consequences. So if the person is ascending rapidly to high altitude and not taking a rest, and he is not being provided with any oxygen supplement, so these are the consequences, and death can take place. To avoid all this, best possible is ascend slowly. So if a person is going at high altitude or going for mountaineering and trekking, the best advice given by physician to him is ascend very slowly and can withstand far low atmospheric oxygen concentration than when ascend rapidly. This process is called as acclimatization. So it is very important. So here we will be learning what are the physiological acclimatization processes. So if somebody is going for mountaineering, or especially for army persons are going at high altitude from sea level, so these are the advices which are given, and let's see how the body start to acclimatize to the high altitude if you are ascending slowly. So changes of acclimatization first to low partial pressure of oxygen is there is increased pulmonary ventilation. Here there is a role of arterial chemoreceptors. Immediate exposure to low partial pressure of oxygen, it stimulates the arterial chemoreceptors to about 1.65 times normal. Remains for several days, increases ventilation still more up to about 5 times. So by increasing the ventilation, we are able to increase our partial pressure of oxygen inside by taking oxygen so many times. So this is the phenomena basically. This at our heart we are having chemoreceptors at carotid bodies are there, aortic bodies are there. These are the nerves, vagus nerve and glossopharyngeal nerves. So from here and at this carotid and aortic body we are having oxygen sensitive potassium channels are there. So if oxygen is deficient, we'll go in detail at arterial chemoreceptor. I'll not go detail right now. So these are, just remember, these are O2 sensitive potassium channel. So if there is deficiency of oxygen in them, potassium outflux reduces, leading to depolarization at the aortic bodies. So impulse goes from here, it goes to DRG, that is dorsal respiratory group of neuron and ventral respiratory group of neuron, and this will lead to stimulation through phrenic nerve, and there is increased rate of ventilation. So in this how rate of ventilation increases. But when rate of ventilation increases, what is going to happen? Because of that, CO2 will be excreted more. That can lead to decreased CO2 level. So it can again have second consequences. Decreased CO2 will have a negative effect on respiration. This will suppress the respiration. So this again, there are central chemoreceptors are there. So decreased CO2 level will inhibit the respiration. But again, this effect goes off within few days. So decreased CO2 inhibits the brainstem respiratory center, but ensuing 2 or 3 days, this inhibition fades away, allowing the respiration center to respond with full force and bringing back to the normal. So these are the two effects initially. Initially we are having hyperventilation. Because of that, CO2 level reduces. So again, this will inhibit the respiration, but in 2-3 days, due to acclimatization process, respiration comes back to the normal. Now the hypoxia itself is a stimulus at the kidney to release erythropoietin. If you have gone through the erythropoiesis process, there is one protein, so there is a hormone called as erythropoietin. If it is stimulated in response to hypoxia, this will lead to increased production of RBCs. And ultimately in that process, hemoglobin count rises. When there is more RBC production, more hemoglobin. So from 15 it becomes 20 grams. Now our carriers have increased now. So apart from, if the oxygen is deficient now, whatever oxygen is coming, we have got now more number of vehicles to transport the hemoglobin. So this is again one of the process of acclimatization. Third process, that is hemoglobin count increases. Fourth, there is increased diffusing capacity. Now it has got multiple reasons for that one. Basically, pulmonary capillary blood volume increases. Basically, when there is in the process of acclimatization, as we are going up, hypoxia stimulates again the heart also. There is increase in cardiac output to about 30%. Because of increase in cardiac output, more blood will be pumped to the lungs. So pulmonary capillary blood volume rises, which expands the capillaries and increases surface area through which oxygen can diffuse. So it is increasing the diffusion area. So because of that, more doors are open now for the oxygen to go for diffusion. So these are the things. Now best way to prevent, how to prevent this, all the consequences: gradual ascent with adequate time for acclimatization. So if you want to avoid acute mountain sickness, gradual ascent is recommended. Above 3,000 meters, a graded ascent of 300 meters from the previous day's sleeping altitude is recommended. Means when you reach altitude, stay for 1 or 2 days there, acclimatize your body with the respiration rate, with the hemoglobin, everything, then do the second ascent. So spending one night at an intermediate altitude before proceeding to a higher altitude may enhance acclimatization, and this will reduce the risk of acute mountain sickness. So these are the changes of acclimatizations which are happening now. But if the person remains there again for some period of time at the high altitude because of some other reasons, so he can go from acute to chronic mountain sickness also. Because whatever now there is acclimatizations are there, they will be temporary. They can lead to complications also. For example, a person who remains too long at high altitude, as we know, red mass is increasing, hematocrit is increasing. Now this is going to increase the blood viscosity. This will reduce tissue blood flow. Because of increased viscosity, will start to fall. Hypoxic vasoconstriction effect that normally operate to divert blood flow from low oxygen to high oxygen alveoli, it increases. Pulmonary arteries becomes constricted, because we know one of the important response of pulmonary arteries in response to hypoxia is vasoconstriction. This will lead to rise in pulmonary blood pressure, that is called as pulmonary hypertension. Right side of the heart will enlarge because of pulmonary hypertension. There is more pressure on right side. It can lead to congestive cardiac failure, and death often follows unless person is removed to a lower altitude. So if a person is going to high altitude, he has to be there for only temporary. He has to come down. Otherwise, he can land up in the complications of hypoxia. So people who are living at low altitude, they cannot withstand the high altitude for more period of time. It is only the natural people who have taken birth there. There is some already right from the birth, some changes are happening in the body which can help them stay at that period for long period of time. But any person living at sea level, he will need proper management. So natural acclimatization of natives at high altitude, those who are born there, for example at Himalaya altitude about 13,000 feet, some people are born there and they're staying there, especially Peruvian Hindus live at altitude of 17,000 feet. Acclimatization native begins in the infancy basically. The chest size is greatly increased whereas the body size is decreased. The heart largest than the lowlanders, and if you see their hemoglobin dissociation curves, it is totally different. This is for at sea level dwellers, but in that you can see the graph is going up there. So already by birth there are so many adjustments are taking place in the body so that they can accommodate and they can survive there. So these are the changes of acclimatization. If they are managed properly, person can survive for some amount of time, but he has to come down, and people who are taken birth there, they can survive in a better way. So here we are finishing physiology of high altitude. Thank you.